Hey everybody, W1VLF. We're going to take a look at some electronic components today. Everything from power transistors to crystals to light bulb filaments to diode connections, the spacing on receiving and transmitting capacitors. We'll even look at some 1N34s, some LEDs, litz wire, diodes. There's a high voltage diode which you'll be taking apart, and probably one of the more interesting things is going to be this IC here. This is a really old Eprom from well, I won't say what year it's from, but it's kind of unexpected. Maybe somebody out there will know. Anyway, so here is what we're using today. This is the Andon Star 207, I think it is. I've always wanted a microscope, so I decided I'd go out and buy one. And this type, we use them at work for surface mount work, looking at circuit boards and whatnot. But decided, hey, maybe somebody wants to see what some of these components look like inside. Quick preview there. That's a core that's less than 1/8 of an inch in diameter, and I am zoomed all the way out. So we're going to look at a whole bunch of these components and just have some fun. So it's super hot down here, even down here in the air-conditioned basement. But so I don't want to do anything. Oh, the other thing that's going to be interesting is probably people have seen the filaments before. But anyhow, let me get set up for this, and we'll go from there. W1VLF. Okay, folks, we're back behind the camera here, and gonna look at, first thing I think we'll look at is resistors. There's not all that much excitement there, but I don't know, how many of you have ever pounded one of these little, what they call sand resistors? It's got either a cement or sand type covering here, case, and then the resistive elements put inside, and then it's filled with some sort of a cement or maybe even a concrete or something. But these things can get pretty hot. So this one here is 75 ohms, and we'll take a look at it under the microscope here first, as it stands right there. That's the resistor. Okay, big deal, right? And then on the other side, you can see here how they're sort of potted in there. And this one's 75 ohms, so I guess I would expect the wire to be kind of thin inside this particular one. And here's a view of it out of the enclosure. Now let's bring that into under the microscope. Okay, it looks like some kind of rod there. We'll go in a little bit closer. Okay, so on the right and left sides, you can see the wire going out. That's this guy right here. And then they're wound with some sort of nichrome wire. Okay, which is pretty small. So let's leave this right in the center here, and we'll bear down on this a little bit and see if we can get a better view of what this looks like up close in the wiring. So we'll drop it down quite a bit, and right in there we can see some of the sand and stuff that's still on there. And of course what you're seeing here is a lot of the remnants of what was in there before. So I'll get it a little bit tighter here. We'll go all the way down and see how close we can get to this, looking at each one of those individual wires. Now this microscope, by the way, I am not sponsored by this or anyone for any of this stuff, but there's each one of those wires. So that's a pretty small wire. All right, I'm going to move this back up and change the focus back to very wide again. And we're going to look at another sand type resistor. This one here is 0.68 ohms. So being very, very low resistance value, I would expect this to have a lot less wire and significantly thicker wire. Let's see here. Let's focus this in. Okay, so that's kind of cool that you can actually, I could read the components. Imagine that. Some of these things are written so small that you can't read them, and you'll see that as we go on. Okay, so let's see what that one actually looks like under the microscope. And as suspected, there's the wire itself, and it's folded up in sort of an accordion fashion instead of being wound on a core. I'll try to hold that in place, and we'll just focus this in a little bit better. So you can see the wire's much thicker and there's a lot less of it. And depending on the makeup of the nichrome wire, they can probably make this any resistance that they want. All right, so that's resistors, no big deal there. Oh, I have a small drone motor here that was out of a, out of a drone. And that motor is 3/4 of an inch in diameter, and each one of these little cores or poles are probably, oh, I don't know, it's hard to measure, but way less than 1/8 of an inch in diameter. So let's take a look at it. And it's kind of cool to be able to see that stuff, right? So if each one of these, let's see, do I have a pointer here I can use? Let's see, yeah, let's try using this for a pointer. If each one of these is less than 1/8 of an inch in diameter, these pole pieces or the windings, then these wires are incredibly small. By the way, there's the magnets. So in this particular motor, the magnets rotate around. In a lot of motors they do, instead of the center. The center is stationary, but these magnets, tiny little magnets here, are what rotate around. I'll just go down a little bit more and take a look at each one of those pole pieces, or excuse me, one of those cores. Okay. The other thing is depth of field changes too. When you can't expect to see everything in focus at the same time when you're looking at it under relatively high magnifications. So anyhow, that's I'll go back up, and that's the drone motor. It's side A, and of course side B. I think maybe you can see it rotate this way. Yeah, that's the part that has the magnets on it. And you can even see they have a little barcode or QR code on there. So we'll just throw that off to the side. Another device that a lot of people out there might be familiar with is, and this is not a mini circuits piece, but this is an equivalent to an SBL1, right? The mixer that's encapsulated. I heated this one up with a torch to pull the cover off. This is a double balanced mixer, all right? And I'll show you what's inside that, and you can see the transformers, the diode pack, and everything. And here we are at fairly low magnification. I'm not sure if this is the input or the output transformer, but here's the input ferrite transformer here. The 4 diode stack is here, and here's the output transformer, or vice versa. I can't remember. The blue pin signifies something, and I don't remember what that is. But anyway, so there's 4 diodes underneath this little stack here, and we'll zoom in on the transformer itself too, because that one is really small. So let's focus in on that. And again, I just thought this might be fun for some people to watch. This might be boring as hell for some people, but I thought it was interesting. So I figured I'd make a video out of it. So there's that core, and I'll pull this out and measure that with the calipers, just for the hell of it. And that whole core is, I don't know, less than 1/10 of an inch. I don't know what the wire is on there, but we're looking at some pretty small pieces of wire and some pretty fine windings. These are soldered. A lot of the stuff that we'll look at later on are spot welded in place, but this looks like it's all been soldered in some fashion. I don't know if you could do that with a machine or not, but sure looks like somebody had to do some pretty small work. Anyway, we'll toss that baby over to the side. I don't know if I want to mix it up here or what. Well, now let's just go through them one at a time here. How about this? These are what they call CATV hybrids, or amplifiers that you would see in a lot of cable television amplifiers out there. And this particular one, these run on 24 volts. Oof, I guess I got to go a little higher, actually, and to focus it in. There we go. These are, well, let's see if I can get the, there's the model number, the Motorola number for it. This is a Motorola version, okay? And on these, refocus. On these, there's, what is it, 7 pins? That very center pin is 24 volts. This pin on the right-hand side, and this could be vice versa because I don't remember the actual pin configuration, but this is the output pin or the input pin, and this is the other pin. It's a 50 ohm amplifier, super high linearity, because there were typically 70 carriers running at reasonably high amplitudes. So you need these very, very linear devices, and we call them hybrids. And so they're made of push-pull pairs. And the other 4, 1, 2, 3, 4, those are all ground. So extremely simple. 24 volts here, input 50 ohms matched over here, and output 50 ohms matched over here. And these things have bandwidths up to 700 megahertz, 800 gigahertz. I didn't look this one up. But let's see what's inside this. So here we go. Here we are again. Let's see, the bigger wire, would that be the, I'm not sure which side would be the input. I think this might be the input side over here. So there's a very tiny toroid transformer, and you can see some of the whoops, let me get that focused in better. Some of the chip capacitors and things like that are in the circuit board that are on that ceramic substrate. And these are the transistors. Okay, here's a transistor. So there's a pair being driven here, and I think maybe this is the other pair being driven here. So, but it's a bunch of push-pull amplifiers. So let's get a little bit closer on one of these transistors. So we'll zoom way down. Oh, I always forget which way to turn the focus. And these bonding wires are really very small. And take a look. If I ever get us there, come on, guy, come on. Okay, let me get a little closer. Yeah, I know this thing makes a lot of noise when I'm moving it up and down. Let's see here. Okay, let's try and get a little more light in on the subject here. Maybe you can see it. And maybe just a little better focus here. Okay. So you can see the wiring. The large square on the outside is probably the collector, and the emitter and base are the bonded wires. I would guess that the single wire is the base, and that the 2 wires that are in parallel are the emitter, and that's the transistor in the very middle there. Everything's gold plated. But you can look at the ends of those wires, looking at the end on the chip right now, and now looking at the end over here on the gold base. I'll put that in the center, and you can see, I'll focus it in even more. You can see how these things are sort of spot welded in place by the texture where the wire is flattened out. Now the other thing about this microscope is the resolution is relatively high, so I can zoom in on those and digitally, and you can really get a good look at what happens in there. This is all happening at super fast rates, right? There's not some guy with a little handheld unit doing this. It's really quite amazing. So let me pull this back up, and we'll go back and focus again here. So we can go through and look at the surface of the whole thing to see what's inside. Here's something interesting. What are these guys right here? I don't know what these are. I wonder if those are some sort of series resistors, some sort of resistance elements. Let's go down. We'll go down. We'll get a little bit closer and see. No, I'm not sure what those are. Somebody might have an idea. But this guy in the center, the zigzag, that to me looks like, right, wow. You know, this is a tiny, tiny piece of solder I'm using. Anyway, that looks like an inductor, right? That typical strip line type of an inductor. So anyway, a TV hybrid. Oh, and the other thing is, this is a, just to show you, this is my finger. No. This, when you look at it here, well, maybe it'd be better to see it up here. This is a solid block of copper right here, and it's used as a heat sink. These things typically draw an amp, so 25 watts of dissipation, 750 mils to an amp. An amp would be 24 watts, right? At 24 volts, 750 to an amp, depending on, you know, the channel loading and everything that it was designed for. So you got to get rid of an awful lot of heat here. And that plastic cover, again, is just kind of for identification purposes and to keep, you know, dust and crap out of the component. Since we're on power devices, I think we'll go over this device, right? Power transistor. Yeah, I kind of hacked it up a little bit on the outside, but that's not really what we're interested in. We want to find out, oh, you know what this was? I think this was a 3772 or a 3055, one of those typical transistors that you would see in like an Astron power supply in parallel, but it basically a DC pass type transistor. So the lid comes off, and when you take the lid off, you can see a few components in there. But let's take a closer look, right? What else are we going to do? Okay. So, oh, the other thing is 3 connections, right? The collector is typically the case, the emitter, and the base. So let's take a look at those and see if we can figure out what's going on here. All right. Well, let's see. Can I focus this in a little bit better? Wish I could go a little bit higher with this, but I can't. So, well, I can tell you which one is which. This is the emitter base. Okay. Well, maybe I can't. But oh, yes, I can. Yes, I can. Okay. So if you look at these devices, right, look at it very closely there. You can see that this is one transistor here on this little chip. Remember, this is a super small piece of solder. And this is a much larger area. It's connected to the surface of this device, which means that's the collector. And so this is probably the emitter here, and this is the base, the small area right here. So I just find it fascinating. And here's the other one. So both of those bases are connected together. And again, you could see, look at the spot welding that they do. And if you've ever seen any semiconductor manufacturer or component placing, these things don't happen, you know, slowly. This is like bam, 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 bam. It's amazing. So we'll leave this device, but first I'll just zoom in really closely on one of the chips, okay? Let's go down there and zoom in on one of the chips. Okay. There's a pretty good, you can see how it's zorched right there, right? There's the base. And we can go even lower, but let's see. Wow. So there's the base inside of a twin 3055 or twins 3772. I forget which one it is, but anyway. So there we go. All right. So let's look at a couple of other things here real quick. I have a whole pile of these 1N34 diodes. Remember those, the germanium diode? And when I was first messing around with this, I said, hey, look at this. I got a bunch of these germanium diodes. Let's see what it looks like inside those. And so here's one with way too much light on it. So we'll pull those away. Here's one. And not a lot to see there. It just looks kind of like a I don't know, a little block of something inside there. But that's a 1N34. And if we get a little bit closer and focus in a little better, you know, just not a lot to see. So I thought, well, let me look at the other one, because there was two on this unit here. I'm going to look at the other one. Let's see, where is this? Is this it? Okay, here's the other one. And I'm like, what the hell? Is there sand or something inside these? I'm like, what is that? So I zoomed in a little bit more. And there's the glass surface, right? But there's the inside, right inside. I said, what the heck is in there? I'm tapping the microscope and you can see. I think what happened is this diode fell or blew and the whole thing shattered inside. I'm holding it still, but I'm tapping the microscope itself, so you can see that it's, you know, quite a bit of there's motion in there. And then again, we'll move back over to this one and refocus. And it looks like a solid piece. So that was kind of an interesting discovery. At least it was for me. So we're going to pop up here. And you guys have seen these things, right? Maybe not. I don't know. How many of you guys ever took apart a laser printer just to get the precious laser diode? Well, this is what they call the sled. And it's adjustable. It's a big aluminum piece, cast aluminum piece that's machined out. There's a lens arrangement in here that focuses this, which is the laser diode. And it normally fits right in the back, and this focuses to a point so that you can write with the laser. So let's take a look at just the laser diode itself. Okay, the back side is, let's see, where are we? Getting better at focusing this thing the longer I go here. So there's the 3 solder connections. Look at all that rosin in there. I guess they weren't not up to NASA standards. But the more interesting side of this is, if I can get it to lay flat, we can see the laser diode and, oh, let's see. I got to position this just right. All right, so there's the glass window, probably a borosilicate glass window in there. And we're going to focus a little bit deeper. And you can see a bonding wire. I'm going to bring this down. I don't know. I wish I could get it to lay flat like this without a reflection. I had this in the... Yeah, okay. That's a little bit better. There's a bonding wire. And you can see in the back the 2 different elements, right? On this side is... one of the wires coming out, and on this side is the other wire coming out. There's the binding post, and there is the laser cavity right there. Right now, that's way too small to do anything with. So let's zoom in. Keep it in the center here. Okay. So we're starting to see that a little bit better. Okay, with more light on it, but we're going to zoom right in on it. Let's see, can I get any better lighting here? Let's get a little bit better here. So there's a little tiny cavity there, and that's where the lasing takes place. Now I'm still way zoomed out. Let's go right in. Okay, so you can see the bonding wire. Let me see if I can get this thing back in position here. Oh, this is going to be really hard. Oh, I got it. Okay, so let's get the focus. Okay, so right in there is the laser cavity. Actually, you can go a lot closer than that too. But we need light. Once you get down to this level, you need a serious amount of light. There it is, right there. Okay, so now you've seen inside, and I have too. I've never had the opportunity to do this before. Well, let's see how big this hunk of solder is as I move it through the pit. Yeah, solder. Well, okay, so there we go. Let me zoom out. Probably one of the coolest things of all. Well, we'll get to that in a minute, but here's another component that you might not have ever seen. Well, I mean that you've seen all the time. This is a crystal. But when you take the cover off the crystal, you actually get to see the little disc that's inside, okay? So let's take a look at this disc. I can't go any further up, so we'll have to focus it from there. Okay, so here's the two wires coming in, right? And this is the crystal. And it's held on by these two little clips, one here and one on the other side. And this makes connection with one side of this crystal, and the other wire makes connection with the other side of the crystal. And when you excite this crystal with a small amount of current, it will literally flex back and forth and resonate and ring. So let's take a closer look at one of these. And the thickness and diameter all have to do with what frequency this crystal will operate on. So there's a picture of the connection, and you can actually see, well, here, let's look at it on the side here. We can see how thin it is. It's a very, very thin piece of quartz. And guys would, in some holders, you can take the crystal right out and either put a pencil eraser on it or write on it with a pencil to change the, or sand it on glass to change, Jesus, clean your fingers, will you? Or change the frequency. Since we're on crystals, I think what I'll do is I'll grab another. Here's a 100 kilohertz crystal. This is, I bought a bunch of these. These are Russian crystals. 100 kilohertz, and you can see these are much thicker. And there's the connection on one side, the connection on the other side, and the bonding. And look, there's some crimping, and they came into a glass envelope like this, and I had to smash the glass envelope. But I would go to higher magnification, but there's not much to really see here because they're not very small components. So anyway, those are crystals. Let's throw that in the pile. This is a number 47 bulb. Right? Everybody's seen those. I don't know if this is a 6 or 12 volt bulb, whatever. That's not the point. But, you know, we look at it under here and we say, oh, look at that. Man, when you look at it under a microscope, that's not just a thin piece of wire for filament. That's wound on a spool. Oh, that's interesting. Well, let's break the bulb apart, which I already did. And let's see. Now we have a clear shot to the filament. All right, and we're gonna really zoom in on this. Oh wait, let me just see where we are. If we're still way up high in magnification, or did we come down? Yeah, let me zoom these back down again. A little bit better picture if I can zoom them down and don't have to use the digital magnification. Okay, so now we're, you know, we could tell it's a coil of wire, but not much more than that. Get it a little closer. All right, now it's really starting to stand out as a coil of wire. Let me just get something here. I had a piece of paper. The white paper might make this easier to see. So let's just try that. Yeah, I think so. All right, so now let's zoom down and really get an idea. Really get an idea of what paper looks like under a microscope. No, of what that filament looks like under a microscope. And we're not laying flat. Let's see. Okay, now we're looking at an actual coil there. And if I were to zoom in on it, you could, I'll do that, what the heck. I'm holding it by hand, so it's probably going to change focus a little bit. But you can see the individual turns on that light bulb. All right, so enough of that one. Let's go. Just for fun real quick, little grounding strap, you know, nothing, no big deal there, right? Just a grounding strap. Let's take a look at that. Really, just some of this stuff is just cool to look at. Others are very, very interesting. So there's there's the individual wires in that grounding strap. Let me just zoom this back a little bit here. And you can see the weaving pattern, which is kind of cool. You could sort of see that with your eye, but under a microscope, it's kind of neat to look at as well. Okay, let's get rid of that. Oh, here's something that's interesting. Point contact type diode. This is a 1N, whatever the hell it is. Don't know exactly what that is. I think it's a 4148. I'm not sure. It might be. But there's your typical glass diode. And if you look right in the center of the glass diode, you could sort of see that bonding wire in there. But we're gonna get, of course, we're gonna get closer. And we're gonna focus. Now the bonding wire and the actual diode element are a little bit clearer. And let's go down a little closer yet. But that's not really a great picture, is it? So let's get rid of that. And let's get I broke one of these open. And here is the actual diode element, actually the wire that's bonded. You can see that again, right? That it's bonded to that. That looks just like the lead, and there's a wire that's bonded to touch something. Let's go to the other half. And here's the other half. And there is the actual diode itself connected to the lead, and that zigzag wire would poke into the center of that. So that's a 1N34, or a 1N. No, these are germanium, but I don't know the number of them. I forget. Just here's something interesting to look at. You know, everybody's seen these things, right? Oh yeah, that's a transmitting capacitor. Well, how do you know that's a transmitting capacitor? Well, because of the spacing and how it's built. So let's look at this spacing that we're always talking about here. Okay, here's a very low magnification, and you can see all the crap on there. Let me try to focus that a little better. Okay, and one set, of course, turns. You know, one set of these capacitors turns, and the other side's ground. The stationary side typically. So that's sort of a transmitting capacitor. That might be a few thousandths, 5 or 6 thousandths of an inch. And here's what we commonly will refer to as a receiving capacitor. So let's look at the spacing on this one. And you can see the spacing is much closer. That's why you always keep your capacitors closed, i.e. not like that. Because if anything hits that, you bend them. It's almost impossible. So let's take a look at that. And these came from Russia. These are very high quality capacitors, just sitting on ceramic, and they're really nicely manufactured. These were out of receivers, you know, radios. These are definitely not transmitting capacitors, but take a look at that. I'm going to go from that one. Let's see if this works. Go from that one, which is one capacitor, and let's look at this one and look at the spacing in between these. Now you imagine if you ever bent one of these, how much fun it would be to try to straighten that out. And I'll turn this so you can see that. Okay, you can see the spacing in between those. You could come down even more, and we'll look. There's barely a thousandth of an inch spacing there. Here, I'll turn it again. You'll see one of the sections starts to move. So almost impossible to square those away if you ever screw one up. Anyway, let's go back up. So anyway, those are the transmitting sort of capacitor, and of course the higher voltage that you want to use, the greater the spacing you're going to need. You know, and you look at that and you go, okay, yeah, wow, quite a much larger spacing. Here's a diode, right? All right, now what's so special about it? Why the hell is it so damn long? When you're in the old days, again, in the old days, This is a TV11S. Okay, this one's made in Germany, I guess. But if you wanted, I'm going to grab a pair of pliers here. If you wanted to make a diode that had a higher PIV, you would add diodes in series, right? This diode is probably good for something like 15 or 20,000 volts. This used to be like a focus diode in a television set. So how would you do that, right? It has a standard line here, plus, and you know, or the cathode, or anode, cathode. Anyway, what I'm going to do is break it apart. It'll be interesting to see what's inside there. So I don't know if you can see this or not. I'll come up here and see if I can. How do I know this? Because I did this a million times. Oh, okay. Well, that's okay. All right, so there's a spring. Why is there a spring in there? Okay, let's get that in the middle. Why the hell is there a spring inside of a diode? Well, here's why. Hopefully this will work. Here's the diode. Okay, you'll see it better in a second. Huh, shit, that worked out better than I thought it was going to. Those are individual diodes stacked in a row, stacked on top of each other. So if you wanted, say, you take a 4001 and you wanted a higher voltage, you put 3 or 4 of them, and you get the, you know, the current wouldn't be any greater, but you'd get the voltage, the higher voltage, right? So here we are. When I want to get up as high as, say, 15 or 20,000 volts at low currents, which focus typically was, there's the stack of diodes. Each one of those wafers is an individual diode. And what's the spring for? The spring was there to keep them all pressed together. I'm going to see if it'll break off, if I can break one off. I doubt it. Wait a minute. Maybe something that's a little stronger than a hunk of solder. Let's see. I could probably break one off right here. Oh, no, but you're seeing it me destroy it. Yeah, there. Okay. So there's a whole stack of these. So how many is there? I don't know. Maybe there's 20 of them in that one, another 10 there, another 30 or 20 there or so. And put them all in the middle here at one time. Let's just zoom right down on that one pack there in the very center and see what it looks like. Okay. I'm going to measure one of these too. But these are all individual diodes. Here's another hunk that fell out over here. And I'll measure this real quick. Or this is the plug that goes on top of it. Measure this up real quick. Each one of these diodes is 70 thousandths, so 62 and a half, 1/8. So they're like a 1/16 of an inch in diameter or something like that, maybe more. I don't remember. But anyway, that's something I thought you guys might be interested in seeing. So there's the old focus diode, and there's nothing else left inside of it. So we'll pull that off. We'll go back up. How come this only shows 7? Oh, I'm looking at my, I hope this is recording everything. Well, we'll find out. Okay, and let's take a look at something else here. Blow all those diodes out of here. Get out of here. This is a piece of litz wire, right? Okay, what's litz wire? What's so special about litz wire? Let's see if we can get it underneath there. There it is. I hope this didn't stop recording. Now, this is, I think, 45 number 46s. And it's wound in a nylon sheath there. So we'll come over here and we'll look at the solder connection. We'll see these wires. Okay, so these are number 46 wires. It's a small inductor I built for something. I don't know what it is, what it was for. But what I'm going to do is I'm going to cut the end of it off here, and then we'll spread the we'll spread the wires out a little bit so we can get a better look at it. So here is the bundle itself. That might be too much light. That's better. All right, now we'll spread it out. Now we're looking at number 46 wire. Okay, and there's 45 of them in here, and they're wound in a very specific pattern for looking at for litz. Oh, wanted to show some diodes here, some LEDs. First thing I want to show you on the LEDs is this is a bunch of LEDs in parallel, series parallel. This is called a COB, chips on board, COB. So this yellow stuff is the phosphor that glows. So when we look at this under the microscope, we'll see, oh, there's a plus and minus on there, right? And there's this like gummy, phosphory, yellowy, gooey crap on there. But if we peel some of that off, we'll find out that there are individual diodes under there. Let me zoom in. Okay, there's an individual diode. There are white LEDs, but typically your white LED is a mixture of phosphor, that yellow stuff, sitting in front of a UV LED. So that's what these LEDs look like, chip on board. And these have a very wide, very broad dispersion, right? They're not focused in any way. But let's look at a different LED. Here's one. This one happens to be red. And you can see, okay, you'll be able to see, once I focus, you can see a little bonding wire in there. Yeah, that's not working out. Let's try it in this direction. And there is a little cup. Oh, son of a gun. Well, there's the cup section right there and the bonding wire inside the LED. But if we look at a better angle, if we could get a good angle on this, we'd be able to see, there it is. The bonding wire goes right to a chip. And that little chip is sitting inside a parabolic mirror, and the rest of this is just for beam shaping. Kind of cool. And then here's an LED I bought a long time ago. This thing is 880 nanometers. And you look at it and it's a grid array, right? So let's see what the grid array really looks like. We'll bring this microscope back up real high. Set it up on a couple of, okay, we'll focus it in. And you can see that there's a grid array of diodes in there. So what is it? 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50 individual LED elements, right? I think this is what, TO3 or something, TO, whatever. I don't know. And there's one bonding wire on each one of these coming in over here, right, to this. And we'll look at that. Let's zoom in a little bit more so we can see that bonding wire, or in this case, wires, because you're feeding so many LEDs, right? So let's go in a little bit deeper. So you can see all the different bonding wires coming from the back. And let's go in and zoom in on, we'll go right in the center of the screen here. And we're going to look at that one individual LED. See the series connections from the top LED to the bottom, to the top, to the bottom, to the top. And then the rest of them are all in parallel across the top. So let's go in close and see, can we get a really good look? Oh, there's a little hair. You see everything under this. Let's get it as tight as we possibly can here. And that looks like about it. I'm gonna have to put more light in there. Well, let's pick one, and then we'll. Okay, so one tiny little chip there. That's pretty cool. Anyway, one more thing I want to show you here. Right? One more thing I want to show you, and this is an early Eprom, right? Erasable, programmable, electronically, or UV light erasable clear window Eprom here, right? This is April 29th on it, and if you look, you see the square, right? The gold square in the center. In the center of that is a chip, and in the center of that is all the circuits. And so each one of these leads on the outside is going to be connected to a bonding wire. So let's start off from the top, because this was really kind of cool. And let's see, we'll get back in focus here. There's that April 29th that I showed you, right, on there. And there's the chip, right? That little gold square. Okay. So now let's zoom down on this gold square and see what those bonding wires look like, and also what that chip looks like. So I have to do this a little at a time. Try and focus the light on there a little better. Okay, now the bonding wires are like absolutely huge, right? Huger, if that's a word. Oh, now we're starting to see a little bit of detail, not a lot, but a little bit of detail on the chip itself. Let me refocus this. Okay, so I'm going to go to full zoom now. This is going to take a second for me to get it back in focus again. Okay, there's the bonding wires. Let me get some light underneath there. Okay. So those bonding wires look a lot like, you know, stuff you'd hold a ship on, comparatively speaking. But if you look at it, now you can see all these different things that are, all the different components that are on there. And one cool thing, if I can still find it again, it's upside down. Let me flip it over. So what year is this chip? Looks like Intel decided, as part of the mask, boy, that's hard to hold. Where'd it go? Oh, it's on this side now. What am I doing here? Okay. Let's see. Okay. All right, so it's going to be on the left-hand side. All right, here we go. This should be it, folks. Sorry. I seem to be losing my my sense of direction here. Ah, there it is. Okay, so it's lower left. Wow. Probably if I bring it up a little bit, position. It's hard to position something when there's like a 1/16 of an inch between the lens and itself. All right, we'll just leave that right there. Those letters are upside down, but now why is this disappearing on me? Somebody's probably out there laughing their ass off going, what the hell's the matter with him? All right, I'm leaving it. Once I get this. Struggle, struggle, struggle. Sorry, folks. I'll probably edit some of this out or not, because I'm just... Okay, there's the 27. Let's put that right in the center of the screen. And we'll zoom in. Okay, so what year was this made? And who made it? Oh, it moved. It's because I bounced. Where? Intel. 1974. That's actually written on the chip itself, and that's the imagine that their logo is written microscopically on the chip itself, and all that other stuff must be gates or something. So anyway, I thought that was pretty cool. I guess that's, I think this is repeating over and over and over, because it only shows 5 minutes up on the screen here. I might have blew a whole bunch of time. What else did I want to show you? Oh, I also wanted to show you really quickly on this Fitbit here. Let's get rid of this. What this display looks like on the Fitbit. Where are we? It says 158 on it. Let's look at that Fitbit at the bottom. Is that also in cubes? No, those are no, that's printed on there. Duh. But there's a 1. So they're illuminating tiny little segments to get that letter, that number 1 there. And also, really quick, I'll just show you something on here. What am we going to do? We'll pull up a picture up here of one of my grandsons or something. Now here's something pretty generic. Okay, we're going to look at the display on the iPhone. What is it? Dots. We'll get those dots in focus. Get them really small. Get them right up there. So it looks as though the blue dots are square and the red and green ones are rectangular. So that's anyway. Sorry this was so long and boring. Then I get this edited up, and if you like seeing stuff like this, leave a like, and also if you want to contribute to the channel, I'll be back with more videos. There's a super thanks button at the bottom. So thanks a lot for watching and sticking with me if you did during this whole thing. Thanks a lot. W1VLF, I'm out.